Hello everyone, I'm Krasimir and today I'll show you how to quickly set up a realistic wine pouring simulation using FumeFX PBD Liquids. This method is physics-based and GPU-accelerated with NVIDIA CUDA, allowing for fast and efficient simulation that take just a few minutes. In our setup, we have a glass and an animated bottle. The animation starts at frame 70 to allow the liquid to settle properly. Once settled, there's no volume loss and we only need to simulate this phase once. So let's get started. First, we need a liquid source to fill the bottle. The fastest and most precise way to create one is by using pro-booleans. Start by creating a box mesh around the bottle. Now go to Create, Compound Objects and select pro-booleans. Set the method to copy and the operation to subtraction, then pick the bottle object. Next, we need to remove the original box element. Apply the Edit Poly modifier, switch the selection to Element, select the box, and press Delete on your keyboard. Now we have our liquid source. However, the final step is to scale it down slightly so that it doesn't touch the bottle walls. Now we will go and create nodes, but since the NodeWorks offers presets to speed up the workflow, we're going to need just a few clicks. Before applying a preset, ensure that the 3ds Max time slider is set to the first frame. Select both source and glass objects, and then click on the PBD Liquid preset. This will create the NodeWorks object and all the nodes needed for the basic simulation. Rigid Body Dynamics, Soft Body Dynamics and PBD Liquid quick presets automatically recognize object names such as floor, pool, fountain, static, ground glass, bottle, sink, bathtub, adding them as static collision objects. However, the bottle isn't static, it is animated, and we will need to create another physics static collision node. Add bottle and set it as kinematic and remove any bounce since we don't want liquid to bounce off the glass. There is just one more thing left to do. For the PBD source, we want emission only to be on the first frame, so we set the range for the time end to 0 as well. Now I'm going to calculate the entire segment so we can check how the simulation looks. This is just a rough preview, and as you can see, the particle count is quite low. The simulation itself looks good, the wine flows into the glass without any spillage. One key advantage of PBD Liquids is that particles can exist anywhere in the scene without consuming additional memory, and you don't have to use any cascades or any other complicated workflows to make it work seamlessly. However, at some point we'll need to generate a mesh from those particles, which is where the real bottleneck is, since ISurf uses voxel grid to compute liquid surface. Inside the PBD Liquid Sim node, there's a main kill plane parameter that is always active. Any particles that fall below the Z value will be deleted, helping to optimize simulation and meshing. I'm going to the first frame, and I like to improve the level of detail, so I'm going to reduce the particle radius to 0.4. By decreasing the particle radius, we get more and more particles in the system and more detail, so we're going to increase the number of physics solar iterations. So I'll set it to 30. And you can see it looks much better now. Now you might be wondering, do you always have to compute those 70 frames at the beginning? Well, the answer is, of course, no. If the particle size and sources are locked in place and you're only refining the simulation, you don't need to resimulate the first 70 frames every time. The first step is to cache these initial 70 frames. Once the caching is complete, we'll disable the PBD source node and add an initial state node. In this node, we'll specify the cache file we want to load. In this case, I'll load frame 70 and set that particular cache file to be loaded at 3ds Max frame 70. Since the first 70 frames are now pre-computed, we can change the simulation range for the NodeWorks to start at frame 70 as well. This allows us to focus entirely on liquid simulation, meshing and rendering. Looking now at the current simulation, we can see that it's moving a little bit too slow. To fix this, I'll increase gravity to 20 and resimulate. This is how the simulation currently looks like, and now we're going to move to the ISurf and liquid meshing. Now let's create an ISurf object. This object will create an ISO surface based on the input particles. First, we'll set the meshing mode to 2 Britson and adjust the particle radius to match the liquid particle radius. We'll set grid spacing slightly below the particle radius. This parameter will determine the resolution of the final mesh. Smaller values will create mesh with more faces, and those values will serve as a good starting point. It is really important to do this before selecting any particle system, because the default grid spacing might be too low, which could quickly lead to running out of memory. The goal is to achieve a smooth surface without over-smoothing, as that would result in loss of detail. Of course, we can hide bottle so that we have a better view on the mesh itself. Now, as you can see, as we are working, the simulation always updates. So now let's do something first. Let's cache our NodeWorks simulation and let's use the cache for all the further tweaking. Now that we have a shaded viewport and everything cached, we can play with the ISurf parameters to get that smooth surface look without these small bumpy groups, and that generally depends on the combination of the particle radius and on the threshold. So you don't want too large radius because it will overly smooth the surface, but you can get something in between with the 0.4 radius and the threshold.
Here is our render simulation, and since we're happy with the setup, it's time to increase the simulation detail for the final version. First, now let's reduce the particle radius by half to 0.2 for smaller particles and more detail. I will leave the number of iterations to 30, which is actually too low for this amount of particles, but I want you to see the effects it has on the simulation. Additionally, to make the scene a little bit more dynamic, I'll move the glass slightly closer to the liquid for a more natural interaction. Now, since we're going to compute the simulation for the first frame, from the first frame we need to enable the source and disable the initial state nodes before starting. Also, for the simulation we need to change the range. So I'm going to set back from the user range to the animation range. We can leave the NodeWorks in cache mode, and as once the simulation begins, it will automatically switch to the interactive mode internally until the process is complete. Now you can see that reducing the particle radius by half has increased the particle count to nearly 1 million. I've created a wireframe preview animation with ISurf, and we can observe plenty of splashing and dynamic movement with some particles flying away from the main liquid. Those particles could potentially cause issues for ISurf meshing, as right now we still have a coarse grid spacing used for particle radius of 0.4. However, when we decrease the grid spacing to 0.2, memory requirements will drastically increase. If such splash happens, there's a built-in option inside the PBD Liquid Sim node called Delete Rogue Liquid, which removes spray particles to maintain cleaner simulation and help ISurf meshing. However, instead of using that option right away, I'll first increase the simulation iterations to a high value of 100 so we can observe how the number of iterations affects the simulation behavior. Now let's cache this to disk again and see the difference from the previous simulation. The difference is quite obvious. With more iterations, we can see that Liquid is a little bit more stable. However, we still have some particles escaping through the bottle opening, but this can be easily fixed by adding an additional kill plane positioned just above the Liquid surface. This kill plane should be active only during the first 70 frames, ensuring that it doesn't remove particles after the initial settling phase. In this case, though, it's not critical since we won't be rendering those first 70 frames anyway. Now the final step is to adjust the ISurf parameters for our new smaller particle radius of 0.2. We'll set the grid spacing to match the particle radius of 0.2. Then reduce the ISurf particle radius to 0.3 and check how a threshold of 4 affect the result. Now let's render the final version and take a look. Now we can see that mesh is much smoother with less splash, so maybe 100 iterations is overkill for this number of particles. So I'll show you how it looks with 60 iterations, which is probably optimal for this scene. Thank you for watching and stay tuned for more Liquid simulation tutorials.